Part 3, number 6, is a tough question because you have to make two-letter words using the letters of the word seen. So initially, this is what everybody thinks. I'm going to draw two spaces, and then how many choices do I have for my first letter? 3. How many choices do I have for my second letter? 2, right? And then you think you're fine, but what's the problem here is that you might have chosen, right, if I choose 3 and 2, well, I haven't considered the fact that it could be both E's. But if I change it to be, well, okay, I have 4 choices here and then 3 choices there. Well, what happens if I chose E both times? And then I have identical objects. So we have to break this up into cases. So first of all, we think about all the letters being different. In other words, we take out one E. Then it is just 2 spaces, 3 choices here, 2 choices there. There are 6 possibilities where the letters are different. The only thing we haven't counted then are if they're both E's. And if they're both E's, it's one choice for an E, and then an E. Add them together, and we have 7 total choices. And this question is very similar to part 4, number 9. So we'll do that one right away as well. So part 4, number 9 is October. And just like seen, there's a repetition of letters. This one has 2 O's. And it says how many 3-letter words. So if we deal with it the same way and take out the repetition, so we just have Okber, then there's 6 different letters, so it's going to be 6, then 5, then 4, or 120 ways where all the letters are different. Case 2, what we haven't counted is 2 O's and another letter. How do we go about doing this? I mean, this can be very scary because you could pick B or anything else. It could be boo, it could be 2, but then it could also be obo, oob. There's so many different ways to think about this. So what do we have to do? Well, first of all, to count this, you could just break it up and do a whole bunch of different cases. Case 2 with C, ku. Case 3 with T, tu. Case 4 with B, and do a whole bunch of cases and count them all out. Or you could do this with one case. First of all, there are 5 consonants, and we need to choose one of them to go there. In other words, there's going to be 5 identical cases. Once you choose that, say you chose B and you got boo, how many different ways can you rearrange the letters of boo? Well, that would be normally 3 factorial, but because you have repetition or identical objects, you have to divide by 2 factorial. Multiply this out, gives us another 15 cases. Add case 1 and case 2 together, and we get 135 in total. The last one that we're going to do together is number 14. Solve for n algebraically, and we have 7n factorial over n minus 2 factorial equals 6n plus 1 factorial over n minus 1 factorial. So we've learned in the past that you can simplify factorials by expanding a bigger one. And you could expand a bigger one until it cancels out another one. The difference in this question is we have a lot of factorials. We got factorials on both sides. So one thing that I would suggest is doing some algebra and putting all of your factorials on one side, numbers on the other side. So can you see that if I divided both sides by 7 and I wanted the numbers on the right-hand side, I could get 6/7 on the right-hand side. If I wanted all the factorials on this side, well, I have an n factorial of it and an n minus 2 factorial already. If I wanted to move this n minus 1 factorial to the other side, I would have to multiply by n minus 1 factorial. And if I wanted to get the n plus 1 factorial to this side, I'd have to divide. The reason it's nice to get all of the factorials on one side is you'll get more cancellation done quicker. On the left-hand side, which is the biggest factorial? Of those four, which one is the biggest? N plus 1. So we're going to start, I'm going to keep n minus 2 factorial down here, keep n factorial and n minus 1 factorial up here, and I'm going to start expanding n plus 1 until I get to something that's on the top that will cancel out. Of course, it's still equal to 6/7 over here. So I was able to cancel out factorials. Now, what's the biggest factorial that's left? N minus 1. So I start expanding n minus 1. Of course, there would still be an n plus 1 down here, an n minus 2 factorial down here. And expanding n minus 1, we get to n minus 2 right away. Those will cancel out, still equal to 6/7. So we've managed to quickly cancel out the factorials. We have n minus 1 over n plus 1 equals 6/7. If you multiply, sort of cross-multiply on both sides, which means multiply both sides by 7, multiply both sides by n plus 1, you will get 7n minus 7 equals 6n plus 6. And n is equal to 13.